Alright, so in this quick video, we're going to look at, we're going to review how to quickly draw a logarithmic function based on its transformations. So the three ideas are right here. The first thing we always want to do is we're going to identify the transformation in the equation. So right now we're just looking at vertical shifts and horizontal shifts. Based off those transformations, I put this in parentheses. We're going to sketch out a new x and y axis based on those transformations. So we know that the real one is here. We're just going to shift to wherever we want our new quote unquote starting point to be based on the transformations. Then from there, we're going to mark our anchor points. Now, our anchor points are the points that we're confident are on our parent function. And we're going to do it based on that new axis that we found. So we're going to look at this one together. The first thing I'm going to find is, are there any transformations? Well, I have a -2 that's being added outside of my function. So I know that that means my thing is going to be shifted down 2. So I'm going to go and I'm going to draw a new axis down 2 from the normal one. So the normal x-axis is here. I went down 1, 2 to draw in this new fake x-axis. And we're going to see that inside of my function, I have x minus 1. We know our x's do things backwards. So instead of going to the right one, that really means I'm going to the left one. Same thing, I'm going to come over here. I'm going to go to the left one, and I'm going to draw in my new axis. So at this point, I'm now considering these my actual axes. And as I go to plot my points, I'm going to use this starting point as my origin. So I don't actually have a point there, but instead of being here where we normally are, instead of being here where we normally are, this one is going to be our new origin. So I can do a check mark here. We've gone ahead and done that. We've drawn in our new axes. And now I need to think about what my original function is. Well, my original function is log base 2 of x. So I'm going to create an xy table for my parent function. Now for logarithms, it's easier to start with my y values, and I like to do -3 to +3. I'm going to have to split this up. Because this is a logarithm, the y really represents that exponent, and the base is found here. So when my y is 3, that really means 2 to the third, which is 8. When my y is 2, that really means 2 squared, which is 4. When my y is 1, that really means 2 to the 1, which is 2, and so on. Now what I'm going to do once again is I'm now going to use these anchor points based on my transformed axes. So knowing my x means how far to the left or right am I going from my starting point, and my y's mean how far up or down. So I actually like to always start with my 1, 0 point. I'm going to color code these as we go. So I'm going to make this one orange. So I'm going to go into my graph, and I'm going to go to the right 1, and then I don't go up. I can also go ahead and do my next one, over 2, up 1. So once again, from my starting point, I'm going to go over 2, 1, 2, up 1. So I went over 2, up 1. The next one is over 4, up 2. So 2, 3, 4, 2. I could even go even further to the 8, 3, 4, 5, 6, 7, 8, 1, 2, 3. Now I can come in and do some of these. The 1/2 -1 is a little bit easier. So the 1/2 is directly between my starting point and 1. 1/4 would be between those. And then we know that this has a vertical asymptote, so it's going to keep getting closer there, and I can sketch in my line. I could even then go through and erase the axes, the fake axes, and we're going to see that I have my transformed graph on this coordinate plane. So those transformed axes really are a guiding point to allow us to place our anchor points, and now we have our transformed graph. I've moved down 2, and we've moved to the left 1. The point that was 1, 0 is always one that you can really find to help you find those transformations.